heavy machines with not much computing power or storage. And nowadays we have like nice laptop, like reasonable. We can have like good storage and also like this CPU or even now GPUs. And also on when we talk about AI, we talk about the TPUs, which are the tensor processor units, which help us to actually make more data processing like faster. And yeah, it's so super exciting that nowadays we have these facilities according to data, which is very important input and to computational power, and also access to this knowledge that I can sit home and start studying about data, about how to understand the problems, the notions, and so on. So that's really cool. And yeah, just to mention some of the examples when we are trying to think about teaching machines, I really like this example from Google. You may check it, which is teachable machines. And we are just playing with the camera in this application. So to teach like the camera how to differentiate things, like as it was before. I think this first example was like the dog and the girl, and only the girl, and trying to make the machine understand with this data that these images are different. So that's how we are teaching machines actually, and that's part of what we are calling artificial intelligence in the sense of machine learning. Which here I actually want to highlight three important points that will make our machine learning to work better. And what do we have here? We have data. I talk about data as one of the main important inputs. Task. What is task? Actually, it refers to the specific task or mission a machine is going to have when learning something. And performance. Performance is related how good this machine is actually working or doing their task, their job. It's really interesting because if you imagine like you are a professor and you want a kid to learn math or like to add or to subtract, and you are giving this kid like examples how to add, and so that's going to be the data. You are like building this data set. So to have all this example for the kids to understand how add and adding summation looks like, what are the rules and where you have to put the answer and everything. And he has the specific task, which is to add two numbers, three numbers, depending on what is the task we are actually giving. And then we can talk about the performance when we ask the kid like new examples to add numbers and so on. And we see like he only reply good, like good answers, like 3 out of 5. So we can see sort of his performance in the sense like how he has been learning to add, and now how is he like reproducing this, how smart or intelligent is this kid like learning how to add. So it's really interesting because based on what humans do and learn, we are trying to make our machines learn. So a machine for learning or for working as intelligent, it might need data, which is the input, and a specific task that's going to work on. And we need to test and measure the performance, if it's doing well or not. So that's why we are talking actually about a machine that is learning about some task with some data, and we just want to see if it's working well or not. And also, when we talk about machine learning, we have to think like, what it is. We have to think about like a sort of infinite loop, like a feedback loop, because this is not something that we are going to work on once and finish and have the final product and that's it. It's something actually that when we have the final product, we try to see how to improve it from different ways, like from the input from the last client, from the final user, or from trying to fix something in between. And basically what we need to know actually is the part of data that we talk about input. And most of this data is coming like raw data, like we have this conversation and then I want to standardize or clean this data and put it in some sort of format, a standard format that the computer is going to understand and try to make its job or its task, right? And then we are going to think about a model, what kind of machine learning, deep learning model we are going to use with this input, so to have a specific output that will help the machine to be intelligent, to predict something, to classify, to give me a number like the price of dollar, like the weather, etc. So this is not gonna finish there, as I mentioned before. It's gonna be like, okay, it's done here, but I'm always looking for feedback, trying to make this machine smarter and trying to have a better performance and trying to apply to all different cases in data, because we usually have some bias issues in this pipeline. And that's what I'm showing here, which is actually an example of a machine learning pipeline where we have these red balls, which is a human bias. And it's related like some pre-idea or something that is coming to our mind of experience. And yeah, I mean, it can be unconscious as well. Like in the example before, I may be building something and maybe I'm doing that myself. And I want to do like, I don't know, classifier of cars. And I only know like, or I can recall like 100 types of cars. And I know there are more, but I just want to try with that. So I just have some sort of bias or sort of limitations. And imagine with this sort of like 100 classification, whatever, maybe it's not enough for for the final user, because because all my system is not working fair. So you can see this human bias like everywhere around, because we human, or we as a team, we are trying to make a machine intelligent, but the input for this are coming from a team, from human team, from people. Like here, the first two are talking about data. Like we are trying to collect data, as I mentioned with my car classifier, and we are also trying to label this data. Like in the example before, like this is a dog, this is a cat, and we are always labeling our data and so on. And in both cases, I can add human bias, like the data I'm collecting, like the label I'm putting to each data. And yeah, so that might cause some problems later on. And even when we have our data ready, we can also have some other issues when talking about the model itself, like training the model, because there is another human or human team that is actually choosing these metrics, these objectives to the model, like how I'm going to train, what's going to be my value for learning rates, what's going to be my minimum acceptable for this one, which is actually like how to measure the performance, right? So I'm also adding human bias there. And when I'm deploying to production as well, there is another human team working out there. And as I mentioned, I can show this as a final product, so I can see the user, what is like the user perceiving and understanding and learning and working and so on. And yeah, from here, I will always receive this feedback, trying to make my model better itself. So it's very interesting in machine learning that we're always comparing like the model with itself and trying to make it better, to work better, to understand more data, to be faster. Yeah, but we may have also this problem. And that's why it's important actually like to have multidisciplinary teams. Like not only engineers, but also like designers, I don't know, people from marketing and people from ethics and AI, that everyone can like work together and understand what we are trying to do and add from their areas of expertise, like suggestions and so on. So that's very important. And I really like how Google itself is addressing this, because they have been creating this awareness about what is actually going on, human bias, what is the problem, what is the problem of not having a multidisciplinary team, and so on. You can also find more if you check like Google ML Fairness. And there is another project which is called People Plus AI Research, which is super cool and is like talking about AI and machine learning, not really from the technical side and like TensorFlow Colab and so on, but also like how you actually build a product powered by AI. Why AI will be important for this why AI is important for this product. What's gonna be the final effect on my user? And yeah, it's really interesting because it gives you the basics and foundations about AI, like also the terminology when we talk about bias, learning rate, and so on and so on. But also it helps to build these multidisciplinary teams, like where everyone is like adding some important value to the product we are trying to work on. So if you give a check, it's called People Plus AI Research from Google AI. It's a very nice job they are doing. They have like different sections and they're explaining like these concepts, but not very like technical, but more practical. So more people can understand what is AI and how it works and why we need like people from different backgrounds and how are the real problems that are actually happening with our smart systems. And yeah, going back specifically to machine learning, let's talk a bit about the different sections, parts of machine learning, which is actually some books, papers. They talk about three parts of machine learning, of three types of classifications. However, there are other practicals and papers and so on that are talking about only two classification, which is mostly based in the type of the data we have in the data set. I have mentioned before data and label, which is like showing this is a cat and this is the dog. But there might be also data which actually has no specific label. So you just have a bunch of data. You're trying to figure out what to do with this data. And this is not labeled data. And this will like be better in the side of machine learning and supervised. Because when we think about supervised learning, we really associate with the label, because we are having like the question and the answer, like the data and the label, and we are trying to train our model with this information. So we are sort of supervising this learning. Like you have the question, you have the answer. So computer, you have to understand this and learn how this works and what are the patterns and so on. So later, I will give you new data and you are going to give me the labels, like the answers. But this is mostly how supervised learning works. On the other hand, if we just have a bunch of data and it's not really like question answer, we just have like all data and we are going to try to get like a sample, like very significant sample from all this data, or in the same data trying to find patterns without a specific label and trying to put like in groups. And yeah, so that's why we talk about a data set without a label, which might fit better in the supervised learning, which could go clustering, for example, some application of recommender systems or customer segmentation, and also in the dimensionality reduction. We have big data visualization or structure recovery. But on the other hand, as I was mentioning before, supervised learning, we can talk about applications about classifications, like image classification, identity fraud, detection, customer retention, diagnosis, which is actually something that's working in the world, in the sense of helping with the COVID thing. When you have this array X from the chest, so to see your lungs, and try to classify the image if this is like infected by the COVID or not. So this is part of classification, and we try to optimize this so to make it faster and better, and to try to help as much people as possible, right? Also, another application might go to regression, just to have this other number that might be predicted, such as population growth, weather forecasting. I was talking about money and expectation of life expectancy, and so. So we have like these two classifications very well organized. But I mentioned also there was this other third one, which is sometimes considered, sometimes just add like a specific machine learning there. But it's called reinforcement learning, and it's actually based in what we know as some of theories for learning, I guess, in psychology it's called, or pedagogy, I can't remember. But is this experiment, like if you are doing something good, I'm going to reward, so you're going to have like plus 10 points, or you're going to have a gift, whatever. But if you do something wrong or unexpected to what I wanted, so I'm going to punish, or I'm going to penalize, minus 10 points, or you won't do this now anymore. And this way of learning is applied to machines as well. So we have these examples: real-time decisions, robot navigation, skill acquisition, learning task. Imagine a robot, like small robots. I think there were these robots that can clean houses, and they have to learn to navigate themselves. So they are using this sort of learning, like you put the robot in the place in the dining room, and it's just moving. It feels like crashing, like punished, like minus 10 points, whatever. So the next time the robot is going to that direction, it knows, like, no, I learned there, I get punished, so I should go somewhere else. And that's how they sort of learn that. And it's really interesting. I've seen different examples of gaming, like I mentioned before, as well as this I don't know if you know this Mario Kart, this game. It was quite old, Nintendo. And it's really cool. And I've seen many examples, like the game is like playing itself, and obviously at the beginning it just goes straight, so it dies, and then it starts learning. Like if it go only straight, I will die totally. So I just start jumping and showing, and it's learning. It's learning with the environment how to survive, or how to accomplish the mission, the task we're actually given. So that part is super important. And just to mention some examples about machine learning, and I'm sure you may know many other more. We have the translation, which has been which has actually improved a lot this last year with the Google Translator. There has been these games. I don't know if you know this game. Actually, is we call it here like it should be like 3 in line or something like that. It's really fun. You play with 2 people, like one against other, and we are just trying to get these 3 of your same sign, like align it, so you win. And here the machine is learning, like I have 3 options where to put my sign. So I see if I put it here, I'm winning because I have 3 in the same line. So I have my reward. But if I put somewhere else, nothing is happening. So that's why it's learning. The classic spam classifier. So to classify where is the spam going or not. The chatbots, which is a really cool example about also like working with natural language processing. And I know it's been helpful also this last month with this pandemic. So to answer and give like answers to like the most frequently asked questions to people and so on. So just to mention some examples, just to close this part, to talk about what is like the formal definition, since we have already seen examples and how it works. I like this definition from the 1959, which is actually saying that machine learning is this field of study that gives computers the ability to learn without being explicitly programmed. If you remember the beginning of the computers, they always need instructions to do stuff. They always need to be like programmed to do like a specific task. So here is given the idea that I can have this computer which has the minimum from programming and sort of understanding, and then it itself can start learning and doing things like getting activity, like being intelligent as human. And yeah, from this concept, which I really like, from 1959, we go like a bit more years forward. And Dan Mitchell, if you're very interested to learn like much more details about machine learning and the different techniques that they exist and so on, he has this book from the 1998, I guess, which is super cool, and it's talking about all these techniques and everything. And also, I sort of like this definition. It says, a computer program is said to learn from experience E with respect to some class of task T and performance measure P if its performance at task in T as measured by P improves with experience E. So maybe it's not as straight to understand as the definition before, but actually here is addressing important stuff. Like I'm not only making my computer intelligence do stuff, but also I'm actually setting something specific, such as the computer is going to learn from experience, which is actually translated into data. We need data for the computers to learn. And it's going to use this experience of data to accomplish a task because it's trained to do a task and not just everything, because we are not talking actually about like general artificial intelligence, which should be something like very closer to a human being. Like I can talk, but also I can see, and I can ask, and I can do different things. So different, I can think and dream and whatever, because there are the different intelligence. But if you think a little bit about these intelligent machines, like the robot that's cleaning the house, that's its task. And that's what this machine is trained for. So it's smart, but for this task. So that's a bit more known as narrow artificial intelligence as well. But it's really interesting to see, like, we still have a lot of work to make a machine really intelligent. Yeah, as I mentioned, we have to test, we have to measure the performance to see if it's actually working or not, if it's learning or not, because that's how we are going to improve, and we may pass from this narrow to something more general in AI. So that's why this definition is not about learning. And yeah, it's also funny, if you might have seen on Facebook this 10 years challenge. It actually showing like this formula, which is like the statistics, like normal. I've used it also in class of physics, like doing some experiments and just trying to get some data done on regression. And nowadays is one of the techniques actually for machine learning. And it's actually a linear regression. So we have been using. All right, so let's see a little bit of example and data. I've been doing this. Oh, wait, it's in Spanish. Yeah. Anyway, this is one of the basic, like, hello world in machine learning. This is the data. We have it actually from Kaggle. Kaggle is like a place where you can have different data sets and you can see different competitions that for people that are trying to build their data science, machine learning skills. and trying to understand how it works and trying to get into the last information and so. So it's really cool. And they have this example or challenge, which is actually called Titanic Machine Learning for a Disaster. You may remember the movie, the boat, Titanic. And we have a boat, we have people, the boat is crashing, and we have some people that might survive in order that not. So we're actually making a computer intelligent. So to say, if if from this group of people there is a person that is going to survive or not. So if you realize, we are talking actually about a classification problem, right? As we mentioned before. I'm just trying to classify if this person is alive or not after the disaster. And we are going to see in a bit how this data is working. But basically, what we actually need for playing with this example is I should divide it like in 3 parts. Like the first is related to data. We have talked about the experiences that our machine is going to have to learn actually something. And we have to talk about like analyzing this data, like cleaning this data, and that's a lot of work actually. And we should focus very well in doing this job because imagine we don't pay that much attention to data, and then we have like whatever on data, so we have like garbage, and we have a good model. The output is gonna be whatever, because our input was not really nice, was not really like a standard. So that's why it's very important to actually work in this first part. And then when we are ready with the data, good data, we have a nice data set, we can actually build our model, our prediction model, that's going to classify this person is going to survive, is not going to survive. So that's really interesting there. And that's where we just focus on the model itself. And then when we actually have a model that has been trained to do a task over the data, we need to measure the performance. Is this actually classifying well? Because here we are also talking about a supervised machine learning problem, because we have the data and the label. Like for training, we know if this person is going to survive or not. So that's it. And this is part of the data set, actually. And this is super interesting because this is like a table where we have these columns, we have these rows, and actually the columns are giving the information, which is oh yeah, tic-tac-toe, cool. And these columns are giving the information what we are going to call features. Like these are the features for this exercise. And we have like passenger ID, survive, class, sex, age, and so many columns, so many features. And actually each row is going to be an example, a sample. For example, this first row is actually giving me data about Mr. Owen Harris' room, which he traveled in class 3 and he's male, 22, and so on. And if we go to this specific column or feature, we see the label that we have been talking about. So I have all this data and I have this label. And in our first sample, we can see 0, which means that this person has not survived. So we are just classifying here, like survive, not survive. And each row is actually a sample. So here, I only have info from 5 people. And if you see, like trying to get some pattern, trying to get some info specifically, you can see like only female survive here, which can be biased because I only have 5 people data from, I mean, just 5 rows from these people. To make my model smart intelligence to understand who is going to survive, who's not going to survive. I need, of course, much more data. But, oh, I have the link here. I have the link here. I don't know if you can see here. Yeah, this is just an example, but I would recommend to check the Titanic in Kaggle, which is also showing tutorials and different techniques to approach this issue. And as I mentioned, these are the procedure, and I'm just doing some basic Python. I've been working with Python this last year, so to focus in what is machine learning and some data analysis, and it's very helpful. I've been using these libraries, which are really cool for data wrangling and data cleaning and so on, which is NumPy and Pandas. And if you have worked before with Python, they may be a bit familiar. You may understand that just putting as MP, for example, here, will allow me to use only MP in all the rest of my code because it's just an alias. So basically, so to work with data, for thinking specifically about data, we have the NumPy, we have Pandas, and just thinking about which technique of machine learning I should apply. And I'm not really building the model itself, which all the details like one step by step. But I'm using this library, this framework, actually, which is sklearn. You may check scikit-learn, maybe. And this one is really cool because it's going to give me options for model selections, and try to find actually which technique may work. And instead of building the different methods for the technique, I just will call the technique like a black box. So to understand what's the inputs, the output, and the evaluations. And I do agree, when you are starting to learn, it's okay to use like Lego pieces to build something and to try to see results. But also it's important to understand the technique itself inside. Even if you are not really coding the detail, it's important to understand how this works, because this will help us to understand all the concepts, right? So that's really cool from here. So we have sklearn, which is super cool and have different methods. Also, just Matplotlib to help with the visualizations, because it's important also when you are like working with data that you can build some graphs and visualizations, and you can also try to understand what's happening with your data there. So to see if this data is going to be like the important clean data I need for my model. So that's why it's important. So if you see, I've been thinking about data, the model machine learning, and some visualization just to see how my data is working and doing everything. Of course, I need my data, which might look like Excel, because it's a CSV actually. It's this document, which is actually from train. We are going to talk about data sets for train and test a little bit further. But just to understand, I'm going to train my model with a train data set from Titanic. So I'm just using Pandas to read an external CSV and put it into my workspace, and just starting working in one variable, which is this data frame original. Just trying to have there all the data I need. So from here on, I'm just using this one so to understand what's all the data I have and how to manipulate it. So we have a TF original, which is if I put like head 3, it will show me the first 3. I can put like 5, it will show me the first 5, and so on. So this is what I have. These are the features. We have passenger ID, the label, which is survive, the passenger class, name, the sex, age, and different codes from the same boat ticket. like ticket, fare, cabin, embark. And here we have to make some decisions as well, like which features are really important, and adding like the sense of decision making to your model if they remain. For example, here passenger ID, it doesn't look like very like decision making. Like I want to find patterns or something like that according to what's your ID as a passenger. I think it's way more important the class you have been traveling, if you're going to be like safe or not. Even the name, we don't care too much the name, because actually we have the class and the fare and the ticket. Sex might be important because I want to see also like how many males and females are surviving, not surviving, age, what age are important, and this because you might have seen the movie. They also talk about like children and women first to be safe, things like that. So it's important. That's why it's to understand all this data, how it's actually working. So just with this TF original, I might use drop, which will just erase those features, and I'm just like quitting like this, erasing these columns that may not be relevant for decision making at the moment where the model is getting trained. So I'm just deleting, and instead of having this big table according to features, I have like smaller table, and this data might be important for me to decide, to understand the decision, like this case, this sample is actually surviving or not. And just playing with some features, because we have to also remember that there are these features that can be categorical, numerical, so that's a bit more of data science, data analytics. And here I'm just trying to find if there are some known values not assigned, and trying to have all my data as clean as possible, as standardized, and then I just will put it to my model. Then just like playing a little bit with visualizations, because I want to see like before this how many women and men, it's like men, this is women, how many women and men are actually on the boat, and yeah, how many are going to survive, how many no, among women, blah blah blah, just playing with Matplotlib, which is super cool to make these visualizations. And then we finally go to model, and we are defining this X and Y because we have the data and the label. And then we just talk about our data as training. And when we talk about our data as test, it means that with this data, we are going to test the model that has been already trained. Like in the example of the kid learning math, specifically like how to act. We are going to give him examples with like questions and answers. So he's going to solve the question and compare the answer if it's working or not. And he's gonna get trained. But when we are trying to measure his performance, like if he's really working, I'm not going to give him the same examples, right? I have to give him like new examples and things. So for him to see actually that he's learning how to solve that thing. Yeah, that's important. Otherwise, we are going to have some issues with our model, with our system, and we are going to talk specifically about overfitting and underfitting. Like overfitting is the model like stop learning, and it's just like memorizing because it's like overfitted. On the other hand, it's like underfitting, which is actually like it's more like generalizing. It's not understanding what's happening. It's like the opposite. So neither case is good because your model will not work as you are expecting to work with it, right? So that might be the issue. That's why we are talking about train data, test data, and with our sklearn, we actually can have this sort of methods. So just to split directly there and not always like doing everything like by hand. Here just use some technique which is called random forest. So to understand better this random forest, you should check a bit about decisions tree, which is actually just like question and one option or the other option. And the random forest is using multiple decision trees. For example, here I'm telling this to use 13 trees. So to have decisions, and it's important to have like an odd number. So to see like this tree says like it's not going to survive, and this tree says it's going to survive. So I can have like odd number to have like different votes because it's like one tree is voting for the classification. So it's really cool if you understand it. And again, here is the sklearn from scikit-learn. So to have actually the classifier itself and not like building a classifier from scratch. I think when you actually understand how this model works and what's the procedure for the pipeline and so on, it's interesting actually to like open this these black boxes and understand a bit more how it's working. So, but in the meanwhile, I'm just like using to understand the problem as an overall. And then I just get some scores to see if it's actually working well. I can do it also like with the method directly there. And then I will do the evaluation with the test CSV directly. And it's supposed to be like a model that has been trained. So I just will put some data and try to get the answers and compare with the label of test to see like how is it working with new data and new experiences of cases. Is this machine has learned the machine actually from experiences before, which are all the trained data set, or if the machine didn't learn, how we're going to fix this now, because it has one task, just to classify with the data if the passenger is going to survive or not. So that's an important thing there. Yeah. Oh no, what I did, I closed it. Let me see if it works now. Cool. Yeah, I should check more. The next one is in English. Let me see. What it is?
Leslie, would it be possible to show us an example of the tree, the decision tree that it generates?
Yeah. You want me to show an example about decision tree?
Yeah, so we can visualize it.
Oh yeah. Actually, I should show you this one, which is a scikit-learn decision tree. You can see. Oh yeah, here is really cool. I mean, a decision tree is. I'm sure we have it. You have used it before. It's just like adding a question and trying to get like a true or false. And each part is like a leaf from a tree. So to have the answer. I know it's a bit more complex because it has like different, how's it called? Like they have different variables to set in the same decision tree. So to have like the different replies, this tree is going to grow. So I mean, from the most general, like one question, yes, no, to something a bit more specific. So it can be very large. That's why also we need these indicators, like how deep it's gonna be, or how much is going to keep growing. Like here, just stop. It's not asking more questions. And yeah, this is the one I wanted to show. I don't know why it's so big. Yes, maybe there. Finally. So here, for example, this is the one I was talking about, which is scikit-learn. That's where I import as sklearn in the coding. And yeah, we are talking about decision trees for classifications, regressions. I just was testing in the Titanic example, which is called ensemble, like to have these different techniques working together, so to see if it's working better or not. And I would suggest you can try this Titanic example with one decision tree, which is like very simple. If you use scikit-learn, for example, is here just from sklearn import tree, and then this tree is going to be a decision tree classifier, and that's gonna do all the work there, like in the figure I showed before. And there, try to see the score for this classifier, if it's working or not working, and to compare with this random forest, which is actually a collection of decisions tree. And you see it's a basic Python, and this sklearn, scikit-learn is super useful to actually just like add these legal pieces, so to start building something and trying to understand in overall how is it working, which data is on the input, at what which outputs I'm getting there. So here I forgot to mention before, yeah, when I have defined my classifier and the technique I'm going to use, I can just put like this classifier fit, which is like training, because we want this model to be fit. It's going to be trained. We just add the data itself and the label that we have been talking about. This single line of code, like doing all this model setting and trying to get the data and training itself. I know it's a bit more complex than we might see it with the neural networks, artificial neural networks, but I really consider this is a good example if you are learning a bit about coding in machine learning. And yeah, then you can play with the same classifier once it has been trained, and to put it on fit, you can put it on predict, so to see how it's actually this model trained and how it will work with new data. As I was mentioning, the new data that I put it before with the test. So here we can also plot and see the scikit-learn itself, what kind of decision tree it has built, and which parameters we can be playing therefore. And yeah, this is one of the basics, and this is super interesting because it's simple, but it works. And yeah, it's interesting because I can go from using one decision tree to use several. As in my example there, I've been using like 13, right? And yeah, I'm trying to see how it's working. Yeah, it's super fun. You can test. Also, scikit-learn has different like data set examples. Yeah, it works super cool for that. Yeah, so that part just mention a bit of machine learning and all the process and pipeline we have been using, and some examples, and how scikit-learn can be a good starting point for getting practice in machine learning. But also, I want to talk a bit more about something that is very used and is very interesting as well. Part of the techniques of machine learning, which are the artificial intelligence, which are the artificial neural networks. And as I mentioned, they are based on how our biological network neurons are working. And yeah, with this inspiration, they have been building like with different layers and so on, and trying to get a different output. And this actually has been leading to this like new technique, which is actually the deep learning. And I really like this example because if you see, it's also sort of classification problem. I just have an image and I want to know if this is going like, this is a cat or not. So I just have 2 points here to have the answer on classification. And just to understand a bit about the architecture we may have when talking about artificial neural networks, we have to consider each layer as with some function and specific. For example, when we have the first layer, which is actually the input layer, we here are receiving all the image itself, which might be this image, to see how what's the task we want to solve, right? And we have this last layer, which is actually the output that's going to give me the answer. And what we have in between these 2 layers are actually the hidden layers. And they may be many or not maybe. Yeah, these are actually giving the more attention to detail to what we want to classify or discover in the data. And you can see it's really cool because according to the image in this case, we have like some pixels, some forms that's going to activate some neurons, like each neuron is like 1 point. So it's going to activate some sort of neurons, which are going to activate the next layer and the next and the next, and that's going to help me give an answer directly. So that's why it's super cool. And again, we can build these layers and each network actually with Python itself. And it's really fun to build just like one neuron, like it's with Python, so to understand better. But when we are also trying to build these sort of complex architectures and so on, actually we want to have like more practically, and we use this framework, which is actually TensorFlow, which is from Google, and it's been released like open the last years, and it's been improved, so to have it more simple to understand and to use for everybody. And it started like only with Python to make all this research and industry work, but nowadays TensorFlow is also working with JavaScript, so to have like sort of image classifier in your browser, and it's also working with with Swift for the mobile development on iOS. So it's been improving a lot, and it's also because of the community, like people testing how it's working, trying to understand the model. As I mentioned, version 1 was a bit more complex, and you had to understand the different loops and threads and many things going on. And the version 2 now is a bit more simple, and you can actually just build as Lego. But it's super cool how the community, like people, developers, they have been testing the different functionalities, the playground, and now the TensorFlow Hub, where you have the models and you can just retrain them or reuse them, and how people are contributing to this with comments and projects, and how we are like making this bigger and bigger. So that's super cool. Here, I just want to show a bit like how these numbers, I mean, here it was the example just with colors, like how they are activating and doing stuff. But I really like this animation because it's showing, yeah, it should be showing. These numbers changing, you see, which are the weights from each input to the next neuron. And this one is super cool because this is a basic example from a classification. This is a task, also known as the IRIS dataset, I guess. And the task is to classify images among these 3 options: Setosa, Versicolor, Virginica. If you see, they are different, but here we're not actually giving the picture or the image to the network. just giving the data from the sepal and petal and so on. So it's very simple. And those are the inputs. So we can see here the input layer, the output layer, which are actually 3, because we have 3 options for classification. And we will have like probabilities about like this input is which output. So we have this value. And in between, if you see, we have 2 hidden layers with a specific math function, and each layer I have like neurons, certain number of neurons, like 1 neuron, which will receive an input, which are like values from each neuron from the layer before, with these numbers that actually changing because these are the weights. The weights are important because it's weighting actually how important is this input for this value. And yeah, so it's working like this, and this layer is giving another answer, which are going to give another inputs for the next one in another. And here, for example, we are using an hyperbolic tangent. Here we have the softmax function. Yeah, these are, for example, names that we have to start getting familiar with, because they are going to be like functions we will see like currently, and that's a bit more where the math is getting in. So yeah, and just to finish this before explanation, here talk a bit more about a neuron, just the unit, which is actually known as perceptron as well. And if you remember the example before, in this perceptron, we actually have inputs, which are like here from the X, from 1 to N. Each one is going to be an input to this neuron, which is going to have a weight that's going to say like how important like is this input. And we just have a sum from this input times weight. And then we have a function, like a math function, to see some values to give me the result, like function here, like the tan h, the softmax. There are so many more. So this is the basic, and it's fun to build this itself only with Python and to see how are the inputs, how the weights are changing, and what kind of answer is given to me. But for something more complex like computer vision or natural language processing, of course, we are using more neurons or perceptrons and many layers for gathering information. That's why here this image is actually showing like the input, the output, and the different hidden layers and how they are connected and so on. When you start learning more about this, you'll see more complex architectures. You will see different techniques to avoid what we mentioned before, which is overfitting and underfitting. Yeah, so I just need to get a bit familiar by now with this terminology and how it looks like, what does it has really inside. Just to close this site, show another example with TensorFlow. Is this challenge? Actually, here is the link from tensorflow.org on tutorials, classification. This is one of the basics as well. This is actually the image itself as an input for this neural network. So to have an answer that's classifying the clothes. And that's why it's like fashion means clothes classification, I guess. But you have images that are actually from 10 types. So you will know beforehand what kind of output you should have according to these labels. So you have a t-shirt, pullover, shirt, boot, etc. And your mission, the data is all this info. We have all this data, each picture with the label, like here, a t-shirt, this one with dress. And the task is to classify another input. Like in the input, I can put another image, which might be a shoes, and I want the answer to be shoes, like to the machine to understand. To show this, I wanted to go to the actually main tutorial in TensorFlow. You can visit here. They have also some other different languages, which is really cool. And what I like from here is that it has the integration. If you want to see the source in GitHub, as I mentioned my code before, or if you want to see it in the Google Colab, which is actually other of my favorites. You want to download the notebook and run it locally. Yeah, so they have different examples here. We're talking about intro, like hello world, basic image classification, text classification, TensorFlow Hub to see different model trains and regressions. Here's what I mentioned with the overfit, the underfit, the save your model to them to later use it, and so on, so on. So it's really cool, and they have different languages. And yeah, so let's check this classifying image of clothing. I'll go quite quickly, so not to go like beyond with timing. I know it's like a lot of information, such as short time, but I think it's really cool to have this sense, like what's really happening with this side of machine learning and what you can try, because that's the most important. Yeah, as I mentioned here, we have 10 options for the output, right? That's actually going from 0 to 9 and just like labeling with numbers the different classes. That's just because of the type of data we are working on. And just want to show you, oh yeah, we have Matplotlib. I opened the Colab, but I just want to show something here. That's all the steps. Build the model, train the model, fit the model. Let's see, fit. It has to be trained to fit. Accuracy, another important term. Yeah, I like this graph because it's like we have 10 options and we are getting like the probability which should be the right answer. And here it says like label 9, which is actually the uncoupled put, which works because it's like accuracy of 95. So my machine is like 95% sure this image is an uncoupled. And something like that. And you can right now just try it. How? You can go here to run with Google Colab. So if you have not used Google Colab before, this is a nice starting point, as this is another service, another page from Google. This is super cool because you can keep this also in your own drive. You have your, oh, it's in Spanish. Huh, sorry. When speaking Spanish, everything is in English, and now it's everything in Spanish. Anyway, oh yeah, let's see. We have this execution, or we can change, and we can use the accelerator by hardware, which is now it's not none. So I'm using my CPU from my laptop, but I can change to GPU. I can change to TPU, as I was mentioned before, like the computational power, which is like super important. So we can test like how is the difference in running. I can share. I like this one. I can share like a normal a Google Drive, Google Doc. Oh, here I'm just like taking the link because this one is not really mine in the sense of this notebook is from Google. So as a Google Drive, I just can make a copy for myself. So here I don't think they will let me. Oh, yes, they will let me. Nice, everyone is now talking to me. They will let me change. Okay, let's go back. I really like notebooks because I can write some sort of tutorial. So I can have this text to explain, and I can have the cells where I can run the different Python code. So if you see here, I have the Python and I have the run button, and yeah, super cool. So basically, what we are doing is like, again, to import what we need to use with Python as our tool. And we have to play with the data. So we need to import the data and to standardize it, prepare data. And then we are going to train the model. We are going to choose the model. Like now it's going to be the algorithm for artificial neural networks. And we have this data as the input, and we're going to train. So we just have the model that fit. And then it's going to be trained, and we are going to have like the output, which is a model trained that we are going to test with dataset test, and to see the performance if it works. So it applies also here. For the imports, so we import TensorFlow, which is our tool to build directly the different neural networks, Keras, which is another update in the version 2. Keras itself was another sort of framework that we had to kind of work together, TensorFlow and Keras, but now it's TensorFlow and I can have Keras as well, so which is nicer. NumPy, Matplotlib, just want to print the TensorFlow I was playing there. If it runs now, I think my internet is quite slow. Okay, let's go fast. And then data. What we do with data, we have to import the fashion means. That's what the data set is called, which is actually 70,000 grayscale images in these 10 categories we have been talking about. And each image is 28 by 28 pixels, and you can see here, like all the images that we are going to train our model to classify. So it's really cool, and you have so much info there, and yeah, it's very easy to follow. Here in this variable, fashion means, I think it never ran. Oh yeah, it ran. We have TensorFlow 2.3, which is cool. So let's see if it's going to run. I think I didn't miss any other. No, it's fine. So we are downloading to this workspace. This fashion means now when I'm loading the data, I'm defining these two sections that we mentioned before, the train and the test. So you remember we have like 70,000 images. And I'm not training my model with all that data because I will have like on hand other data to test my model. So I'm just going to have some sort of the 70,000 into parts, like the train and the test. And remember, for each part, we also need the data itself and the label. So here we are defining train images and train labels, just directly. And same, test images and test labels. So here we have, and it's super interesting that this low data has also defined it. Where is the description? Oh no, 70,000. And if you see here, we have trained. This array has 60,000. So the other 10,000 are for testing, like to check the performance. And we are just changing these classes to label all numbers, so to make it easier and not playing with strings and so on. So just defining my class with the text, and executed. That's number 3. Now I just want to explore a bit more my data. Like what's the shape? 60,000. The image dimensions 28 by 28. It's great scale, so we don't have another value that's showing me the different channels for the colors. The label should be correspondent to the same. So we're just playing a little bit here with this. Just want to go to pre-process the data, because we are actually like trying to get the data sort of standardized. So to have like each image like in the same range of numbers. So our model is not going to be confused with the differences in range. So to misclassify something, right? So we just do this and we divide by 2055. Here it's important to train to be proceeding the same way. So training testing is doing the same. I don't know if that, I don't know if that's working. Yes. I just want to plot, matplot, lib. And it's cool. Oh, I just used dark themes. That's why I don't see this. Okay, so we have the image and the label. And all of them are like 28 by 28 and are standardized among this range of values. Perfect. We have our data. Now, what shall we do? We should build a model. Actually, this one is very simple. It's a very basic, because we are building here a model, which is actually an artificial neural network, and we are defining different layers. How it will work. For example, here is super simple. We are defining keras, which is going to be a sequential, which means layer after layer after layer. Oh, here you have all the documentation. That's super cool. I'm defining a flatten, which is actually the input layer with 20, which we receive images directly like 28 by 28. We have a hidden layer, which is going to be dense because they're going to be all connected. It has like 128 neurons, activation ReLU, and we have an output layer, which is actually dense, all connected, and it's going to have 10 neurons at the output because we have 10 images to classify, right? So this is going to work. Oh, yeah, it's 10. So we have the model there. And our model is ready to receive the data to be, oh, it's not totally ready. Our model needs another definitions, such as the optimizer, the loss metrics, among others. So I won't go very deeply into this. It's just different values that are actually explained here, because we're defining up the architecture of our model, but also we need to define some other important stuff, such as the optimizer, how is it going to work, which metrics we are going to use to measure the performance. And once we have done this both, now we are ready to train the model. And as I remember, is model that train the images we just have. So it's cool. These epochs, it's like defining 10 epochs, which means going to be 10 times over all the data that's going to work. So this is actually working. And it's also printing the loss and the accuracy for each one. And if you see, it's very interesting that we have like high loss, low accuracy. How this is improving? Because loss has to go like smaller and smaller every time, and accuracy has to be like higher. So we started first time with 66, and we finished with 85, which is way better. We just have more model that evaluate. That's fun with TensorFlow. You just have like variable that fit, variable that evaluate, and so on. So it's giving me the last results. Yeah, then we just play with probabilities and try to add, as mentioned, like, so here we have the model trained. Now we have to test with the data, right? And try to see how it's now working. That's why we are talking about this later. We are verifying predictions. We use the trained model with the test data. And yeah, it's super fun, but we have like the same pipeline and the results. And yeah, it's super interesting. It's just you take some time and start like running all these cells and trying to understand how it's actually working. And yeah, so this is really cool. This is one of the examples. I really like it because it's going on computer vision. And if you remember, besides, I mean, comparing to the case before on machine learning, we talked about a lot about features, how to play with our data itself, and also there is this a study case that is called like feature engineering. So to see which column to erase and which not, and how to work with this and so on. And but here, if you see, our machine is not really like caring about my columns there. I'm just showing a picture and I'm just giving the machine the dimensions of this picture and how we are actually like standardizing that everything is going to be measured the same size or in the same proportion. So to have our model, to have the input, to analyze it in each layer that's following, and just to give an answer. And yeah, this example is very basic. If you see, we are only using 3 layers: the input, the one hidden with some activation value, in one output. There's going to have 10 outputs, which are actually the probabilities that's going to be on classifying. This problem, the fashion means, is also better solved with what is called convolutional neural networks, which are neural networks architectures more specialized to have actually these computer vision powers. And yeah, because here we have sort of like 85, which is like, okay, but it can be better. And yeah, we use different architectures and different models. Also, if you are like using more oriented to natural language processing, you use the recurrent neural networks, which are another type of networks. And yeah, it's super cool. I really like the advances with the examples for learning in TensorFlow. As I mentioned, it's also a lot of work from the community of developers. Like we are like testing like even these examples and trying to see how they should be improved and how shall we change things to make more understandable, because it's super important that we can see results, like people are learning or understanding the basics, how machine learning works, and how we can use it like this in different projects. I think I saw in the Google developers or TensorFlow developers a video about people like developers building a classifier for environmental issues, I think. So they had a smartphone to take a picture to the sky, and they could range like how contaminated it was, I think. Something. But it was super cool, and they just been like testing with it, and they've been playing with this TensorFlow and trying to get a product that is actually helping the community, because they can see like when it's getting like bad or better. And yeah, it's super cool, and you can see the pipeline is actually quite the same. That's going like from beginning to end, which we know is not the end because it goes like feedback, but it's actually the same series of steps that's going either for machine learning and deep learning. Well, deep learning should be like shorter because we are not very busy on the feature extraction or this part of data engineering, but a bit more focus on the architecture we're going to use and how we're going to use. So I will encourage you to check these TensorFlow tutorials themselves. You can see here the site for beginners, which is this beginner quick start career basics. You can go from beginner to expert, so to sort of solve same problems, but with different architectures and different approaches that are a bit more like complex, in the sense like different things they are using to make this network better, but to actually as well, as I mentioned, to have a better model that's going to have more accuracy. It's going to work better in general. Some more customizations. You have the videos updated with TensorFlow 2. And where it is? Oh, we have the Tensor board where we can see a bit more of what is it called? Like the playground, I guess. The TensorFlow Hub, where you can find different models. Seek add-ons. So what it is? Oh, this is one of my favorites. Is Magenta, which is actually another product from Google that is helping to generate art. So, there's another example. I think it's not here anymore. But this one, for example, is like generating piano music. So based in what the person is creating and the data they have as inputs, like the different notes on music, they are going to have some output that's going to help to create more melodies and so on. So it's super cool. Data sets, we already have the data to test. So this makes easier to understand that, I mean, to focus on to understand the architecture and neural networks and so on, because you are not really doing all the data engineering, right, with the data set. So it's really cool here. Here is the reinforcement learning that I was talking about, which is actually using TensorFlow agents, which is super cool. So you have a lot of material here to explore artificial neural networks. As I mentioned, we not only have it for Python, but we also have it for JavaScript, which also has like super cool examples to run it on your browser. And for mobile or IoT, TensorFlow Lite, which is super cool and runs super well on small devices, and we have been testing with some friends, super cool. The one for production, Swift for TensorFlow for iOS. You have more info about the APIs and more about their resources. Oh, my other favorite part, which are the community. You can sign up. You can find some TensorFlow user group. You can actually talk about bugs and features that's happening in different parts of TensorFlow. You can have technical questions. I mentioned here the user groups, some other requests for comments or contribute. And yeah, it's super cool. We have, as mentioned, Twitter, YouTube, blogs. The community is super cool. People are very, very active doing all this stuff. And yeah, so let's go back here. So there is a challenge, so many challenges. I know machine learning, deep learning is super huge. And I even just mentioned like 2 techniques and just jump to neural networks. So it's really cool. It depends actually what you want to do with this. I know there are also cool examples with the GCP, talk about cloud, where you can test these models and also to try some auto ML, like the model itself, training itself, like another level. So it's really cool. And before finishing, I'm not taking more time because I know it's very long and it's very like overwhelming with so many things going on there. Just will let some references to cool stuff from Google, which are part like machine learning intro, which are videos, Oh, the book I mentioned, Tom Mitchell, as the same page of Google Developer, the machine learning crash course, and this one from another GDE machine learning fellow. This book is super cool. I really like the very practical and theoretical. This hands-on machine learning. It's talking about scikit-learn, Keras, TensorFlow, and they even have the the examples in the GitHub. And yeah, it's super cool. And just to mention some other AI technical words now that I was talking about Coursera and Andrew Ng. This course is called AI for Everyone. Yes, I took it last year, I guess. Yeah. And it's super cool because it's not only technical, but also a bit more like open for everybody. So you can understand like what's AI, what AI can do, what cannot do. And also here, like mentioning what are the technical tools, like what are the frameworks that I've been mentioned some, also been using. If you are more about research and you want to read methodologies and these research discoveries, arXiv is a good place where to find. Oh, and also I found these papers with code, which I think is super cool in between too, because you have the paper itself with all the details and you have the coding, so you can test what they are saying. But if you're a bit more like coding and try to find more info just to test, you should go to GitHub. And if you just check or search like TensorFlow in GitHub, you will find tons of projects or work from the projects before and how they work, how they do. Super, super cool. And yeah, it's super nice to understand how we are trying to teach machines how to learn, how to realize things, and how this is going to help us. Because, you know, as I mentioned at the beginning, AI is a new electricity, and this is going to be like life-changing for everybody. And that's why it's very important to know actually what's machine learning itself, what are the limitations, what can we expect from different applications, what can we do also to contribute, because I consider also this is a great opportunity, and I found that also for Latin America, and I'm sure for Asia as well, you know, to contribute with research, with applications, to also we as maybe minorities go to propose something with AI, because the knowledge is there, we have the tools, we have also the space where you can run, we can execute actually like this sort of projects in our browser with the Google Colab. You can learn the TPU, for example, from there, and you can run like lots of data and actually there test something. And yeah, I think that's very cool. And that's the important part. Like you can test what we have been like talking about. And again, I know it's a bit overwhelming because a lot of information, since we check also the timeline where AI has been coming on and how they've been changing, I mean, adding or focusing in the different techniques, and how we are working with this, and what can we learn as well with this, what kind of applications, and how this is like changing computer vision and the natural language processing, which are like some of my favorite applications about artificial intelligence. It just makes me like very exciting that I can have really something, some application that is using the camera to distinguish stuff and telling me what's happening. So I think that's really cool. And well, I think we have very few minutes for questions, but it was my pleasure to share with you a little bit of this. I think it's overwhelming because it's a lot of information, But again, I will encourage you to check maybe starting on documentation for TensorFlow, because there are basic lessons where you can actually start learning new artificial neural networks and to see how TensorFlow works, and try to build something and try to test it, because it's something about trying and testing. And well, thank you to the organizers for the invitation. Yeah, I don't know if you have other questions or comments in this last minute. Yeah, thank you.
Hey, thank you so much, Leslie. It's close to midnight there. Yeah. Do you have any questions?
Yeah.
We have about 4 minutes for the it's been very exciting, and like I've been learning a lot. So
cool.
Some of us are probably overloaded. Any questions? Yeah, any questions?
Yeah, but it was really nice. Thanks for sharing the links, because I know I've just been throwing so much information. I will really suggest everybody to check this Pair with Google, which is this project People Plus AI Research. Oh, there is one chapter when it's actually talking about like when to use AI and when not in your product. And yeah, for me it was like, I want to use AI everywhere, but thinking from the product vision and centering your design and product in people is like, maybe this is not the right moment for my product to be powered by AI. Maybe for the data, maybe for the service. And then you just start learning a bit more about how really technology can impact people's life, and when might be the good moment for actually using for actually using artificial intelligence. So it's very nice, and I would really suggest, encourage you actually to read a bit more about this, because it also goes like to different different backgrounds, people understanding how we should play with AI.
Yep. We have a couple of questions. Jasmine, yeah. Jasmine, could you read?
Oh, sorry, which was again? No, I don't. Yeah, I see it was here.
So, Josh, you're asking about how to clean and prepare data?
Okay. Yeah, sorry. Oh, yeah, that's another long chapter. Yeah, it really depends actually what you're like trying to accomplish with your model itself. That will depend the data you have. There are different techniques. I will really suggest you can check data engineering, feature engineering. I just will type it down. Data engineering and feature engineering, which is super cool for starting to check data and wrangling data wrangling. Yeah.
Yeah, I also gave some tools like OpenRefine and Talend. They're open source and free, so you can download them. But yeah, you need to from Jupyter you can do, or Python you can do some libraries. There are a lot of libraries for cleaning the data.
Yeah.
There was another question. Yeah.
Train in the sense of models, or train in the sense of data? I think, Colab is sort of experiment, I've been like testing not much large amount of data, but I've been reading that, yeah, you can have like a lot of data with the GPU mainly. I'm not really exactly sure, but oh, size of models and amount of data, cool. Well, let me think. I've been using more with artificial neural networks. I would say like the heaviest is like very big, like convolutional neural networks or recurrent neural networks. I can't recall right now the size of the model, but yeah, it goes very slow. But I don't think it has like very specific limit of data to something that is more like industrial or something. But I'll give it a check. I will ask. Like we can ask also on the community of TensorFlow. That's a really good question actually. And yeah, so I'm owning that question.
Anything else?
I think that's it. Let me see.
Other questions? Yeah, just turn on your mic. Okay, it's 11:01. So, muchas gracias, Leslie.
Cool.
For staying late with us. Thank you, everyone, for staying with us. If you have further questions, join us at GDG Cloud Manila on Facebook. We are a volunteer group, so we don't get paid for this. It's purely for the interest of learning. You can also join in our meetup page, which is also GDG Cloud Manila. Okay, Brian and Jasmine. Yeah.
We can have a photo.
Oh, it's my pleasure. Yeah, I'm sorry. I've been like late response on Facebook. Yeah, but again, I'm super happy to share with the community. And as Ruben said, it's like we have the drive to share knowledge and to share experiences, which is really good because we can all learn together. And what's exciting from AI, from machine learning, is actually that it's something that's changing very quick and like improving many things. And we can learn like we always have to be learning actually, because as I mentioned, it's like changing and everything. So it's really cool that we can have this space to share and to ask questions, because I've been learning from your questions as well. And yeah, just keep in touch with the community and with their activities they are doing, because it's really nice. And thank you again, guys, for the invitation. It was really good to share with you.
All right.
Oh, I'm sorry. Yeah. Would you like to do a group photo? Please turn on your cameras.
Oh yeah.
Okay. Turn on your cameras. Who's gonna do it? Who wants to do the?
Let me do it.
I'll try doing it also.
One.
Okay, go, Brian.
Okay. Camera on, guys. Okay, 1, 2, 3. Wait. Just waiting for the others. Yeah. Yeah, show your pretty faces. Come on, guys. Don't be shy. Yeah. Okay, let me count. 1, 2, 3. All right.
Thank you.
Is that okay?
Thank you so much.
Thank you.
Have
Thank you so
a
much,
good
Leslie.
of the day.
Good night. Yes, have a good day, everyone.
Happy weekend. Bye-bye.
Good weekend.
Thank you so much.
Thank you, Sir Mil.
Bye.